So I'm going to give you a brief introduction to what Kotlin is, for those that don't know it, and then I'm going to show you some code and tell you why we're going to see code, because, well, we like to see code, right? So for those of you that don't know, Kotlin is statically typed object-oriented language with a dash of functionality in it. It targets both JVM and JavaScript, so you can compile down to either, whether you're deploying in a JVM or you want to deploy in the browser or on a JavaScript platform. It's open source license Apache 2, and we've hit milestone 6. The release of Kotlin is going to be, well, the thing is we're not going to release for quite a while. We're going to hit beta, and then we're going to work with it on beta, and hopefully get enough people to work with it with beta to the point that we're pretty certain that we didn't really screw up badly, and then hit 1.0, which is, hey, it worked for Google. It should work for us, right? So why Kotlin? I'm going to go beyond the dogma here, and I mean there's everybody says, why did you come up with another programming language? Well, if they had said that when someone came up with JavaScript, we would have all been in a better place right now, but unfortunately no one did. But the reason that we've done this is that, I mean, how many of you have heard of JetBrains? Yeah. You might know us for products such as IntelliJ and ReSharper. So we've been developing tools, and we've got tools for pretty much every language out there. You know, I mean, I say, well, if a language comes out, we release a plugin for it. In fact, I mean, when Dart came out, we released the plugin a week after Dart was announced. So we've been developing these tools up on the Java side, not the .NET side, but on the Java side, we've been developing these tools for the past decade in one language, in Java. And yet we've developed plugins for all of these different languages, and we support all of these different languages. And there hasn't been a language that's been found that could kind of suit the needs that we have at JetBrains. That's why Kotlin. And if you look back at all of our tools, the majority of them have always been invented out of necessity, which is what our CEO was saying, which is we needed something that at the time there wasn't on the market, and we decided to do it in our way. Okay. So the design goals of Kotlin are for it to be fully Java interop. It's too early to say interoperability. Point being is that we've got a decade of code, and it's no use for us to write a language to write our new tools in, or continue our tools in and throw out everything we have, because that's just not viable. It's not going to work. So we need it to be fully interop. We need it to be at least as fast as Java, because God knows that we already get complaints sometimes that IntelliJ is slow, so we need to make sure that it's fast. It has to be safer than Java. It has to be more concise than Java, which isn't setting the bar high, because Java is as least concise as it gets. And it has to be simpler than Scala. So how many of you were Scala developers again? Or know Scala or like Scala? Right. So don't compare Kotlin to Scala. You'll find a lot of things that are similar to Scala. Off the record, which I don't know if this is off the record, but I always joke and I say, well, if you want, think of Kotlin as Scala for dummies. But it's easier to understand than Scala, let's say. So what is Kotlin? It's a language. It's got a bunch of libraries, and as I said, it compiles down to the JVM and to the JavaScript. Okay? And we're going to see some of these constructs. So it has a bunch of libraries already. And in fact, James Strachan, whom you might know from Groovy, was the most contributor to the standard libraries for Kotlin. So he did a lot of the stuff here he actually contributed to. The source is on actual GitHub, and you can see the commits. And this is the only microphone with a cable that I've ever had, and I keep stepping on it. So nothing here is final. We are in milestone 6. A lot hasn't changed. There are some things that have changed in the language, but there is a caution that some things might not be final. Okay, so we're going to put Kotlin to the test. And how are we going to put it to the test? Well, we're going to do real-world applications in it. How many of you have actually written anything in Kotlin? Okay, so you are a better judge than me standing up here. Maybe you should do the talk and I'll sit down. So I have done, right now, I've done a couple of applications in Kotlin. And inside JetBrains, we're actually using Kotlin internally. We've written a library which is called KAnnotator for annotating libraries in Java and using it in Kotlin. with our tools. We have written another plugin for one of our other tools, WebStorm. And we have also done 2 internal applications and a third one starting now, right? And I can tell you from my perspective, and believe me or not, although I might seem biased, I love the language. Now, I come from a C# background. Actually, I come from a Clipper background, but that was a long time ago. And then I did Delphi, and then I went into .NET, and then I did C#, and I love C# as a language. And I always stayed away from Java because I just didn't like Java as a language, unfortunately. Kotlin I enjoy. It's got similarities to C#, so it makes me feel at home, but it's also more concise in many areas than C#. So for me personally, I love working with it. And if I were to show you some real-world applications, you would say, and what? Okay, so what I'm not going to show you any real-world stuff. Well, there are some things that you'll see, but I want to focus more on what we actually look for when we're trying to write applications, and then see if Kotlin fits those needs, and then you guys can judge whether it fits it or not. So the features that I'd like, I don't know if you guys would like in a language, is that I want it to be concise because I don't want to write a lot, right? a lot of the stuff that IntelliJ or ReSharper or all of these other tools do is generate boilerplate code for you, right? If we could generate less boilerplate code for us, even better. Safe, yes. Now, safe can come in different aspects. I am a guy that loves JavaScript, but I detest and hate JavaScript at the same time because of the problems that it gives me because of its dynamic nature. But on the other side, I love it because it's so powerful and flexible in certain ways. But I like that safety about languages. I like it to be very expressive. For me, that's one of the most important things because I want a language, when I read the code, to show me what I'm trying to do, not how I'm doing it. Okay? It should display the intentions of what I want to do. Compatible, well, that's an important feature because if you're going to start working with a language and there's no libraries, you're not going to do it all yourself, are you? It's not viable. Modern, that's a little bit hard because what exactly is modern? I don't know. I'm going to call modern some of the new functional things that we have lately. I want it to be fast and I want it to be toolable. Why? Because I don't like doing things manually when it comes to grunt work. So let's see some code, and then you guys can judge and see whether these goals have kind of or not been accomplished. And if you have any questions, please feel free to ask me at any time. Okay. So this is, you can all see that in the background, at the back, right? Everyone can see that? This is as simple as it gets. This is a Kotlin file. We have the concept of packages. We have the concept of top-level functions, which means that you don't need a static class with a static method. If you just want to create a function, you just write it. How many of you actually know JavaScript here or work with JavaScript? Okay, who likes JavaScript? Kind of. So it's kind of the same thing. We have a thing called fun, which it only took, 30, 40 years for someone to call a function fun. And we have a name, then we follow the Delphi style syntax, which is the parameter name, argument name, and then the type. String interpolation, print line. This is imported by default. We have implicit imports, so things that you constantly use are imported by default. We have a main function, and you could just type main, hit tab, and then you get your little main template out there. And then you can just write whatever you want and run this, and everything works dandy, and it all works perfectly. Okay, so that's Kotlin. And normally your applications, well, they start with a main, depending on what type of application you're doing. Obviously, a console application will start with a main. Okay, I'm guessing there's no questions about that so far. So let's go and see what we got in terms of conciseness. Let's see data classes and objects. Okay, so this is something that I do a lot, right? Defining data classes. How many of you define data beans or Java beans or whatever you want to call them, right? So in Kotlin, you have that concept of a data class, which is basically the same thing as a class. And if you prefix it with this annotation data, then what it gives you is out of the box, you see that there's no curly braces. I don't need any curly braces. And it gives me out of the box getters and setters for all of those properties. That also comes with a class as well, not only data class. But it also gives me a bunch of other things. Namely, it gives me things like to string, it gives me things like equals. So it provides me with all that functionality itself, right, without me having to write it. So if I were to run something like this, you can see that I get Joe Smith, which is what I wrote out here. And then I get the customer. This is the toString default implementation of toString for the data class. And then it says they are equal, yes, because it does comparisons. And obviously, if you change something like that and you hit run, then you'll see that it changes. Now, so some of the demos I'm going to run, because I want you to experience some of the downsides of Kotlin right now. And you can see that in terms of compiler time, we're not there yet. Okay, so we'll say things as they are. So that basically is, if you were to write that, whether it would be in C#, whether you would write it in Java, it's a lot of boilerplate code that you don't really need. And the other good thing about this is that it actually distinguishes the concept of a class from what I would use a data class, which is a DTO. Right? Because a lot of times we forget the concept that a class or an object should have data and behavior, and we just limit it to data. Right? And here we make that distinction. Initially, we came up with the concept of tuples. Well, didn't come up with the concept of tuples, but Kotlin had tuples in them, or tuples, however you want to call them. And we had as many tuples as you wanted, and then a function could return a tuple of n values. And then we realized that that's really not good, because it's not really readable. And you lose the semantics when you return a tuple. Unless you're assigning it to something, you kind of lose the intention. So now you do have pairs and I think triples, but apart from that, normally you would recommend using something like a data class. Now, you can also do this with a class. So I could just do a class like this, but then I wouldn't get any of those default implementations for those methods. But this concept still exists, which is basically what this is saying is in the single constructor, I am defining a property of type name. And you notice here that I have val. This could also be var. So val is something immutable, right? And var is mutable. Okay? If I were to not put this, if I were to just leave it like that, then I would be passing in a parameter to the constructor. However, I would not have that name as a property of that class. Okay? So that's in terms of conciseness. What else can we do in terms of conciseness? Let's take a look at functions. Yes?
Any chance that that data object would fire property change events? That's something that you would consider generic enough behavior that most people would benefit from firing those events?
I don't think there's any plans to do anything like that. I mean, you could easily extend that with your own, but there aren't any plans. Right, so let's take a look at yeah.
Actually, one question that does bring up is, are you going to expose the metadata program you use to enable the data annotation? Is that exposed already? I mean, this is a compile time thing you're modifying this class, but is there any way for, would we have to do compiler plugins to get that functionality?
I don't know if we're going to. I can check. Or you know what? Andrei Breslav, who's the team lead of Kotlin, he has a talk and he's also at the booth these 2 days. So that's a question he could answer for you. I don't know if there's any plans on that. So when it comes to function, well, a little bit of conciseness there as well. First of all, you can see that a function takes the parameters and returns a unit, which is our void in Kotlin. But you don't have to say that it returns unit. I mean, that could be implicit. You don't have to explicitly say unit. We have the concept of name parameters and we have default parameters. So you can see here that I have an age in 0, which means that it will default to 0 if I don't pass anything in. I have default parameters here, and I can also name parameters. So you can see that on the name parameters here, I'm setting an age and then I'm setting the name, so I can change the order in which parameters are passed in. Combining that with default, it gives you a lot of options of calling your code and having it do a lot of things automatically for you. And when we get to some of the functional things that I'll show you, it also allows for doing some kind of partial applications of functions. Okay, now I've tried to classify some of these characteristics that I showed you in the slide into different files. Unfortunately, you can't always categorize them, so we'll come back and forth on some of these different things. But let's start with some of the concepts in expressiveness. So here is two strings that I've concatenated with the word and. Okay? And how have I accomplished this? First of all, this is a thing that we have in Kotlin, which is called infix calls. So you can call a method using infix notation, right? But what I'm also doing here is I'm taking a string class and I'm extending that string class. So I'm doing string.and and passing in a parameter input string. Okay? So string is the Kotlin string class. But you can pretty much extend any class, whether it's Kotlin class, whether it's a Java class, any class that you want, you can extend in Kotlin. Okay? If you're familiar with the concept of extension methods in C#, this is the same concept. Okay? You can pretty much extend anything, anywhere. And that extension will apply to the scope where you extend it. So I have this in the package expressive. If I import that package into another package, then I have that extension. If I don't, then it won't apply. Okay? And this is just two ways that I could call this. Now, what does this give me? Well, this gives me the ability to kind of do more expressive code. And I'll show you some examples with a BDD framework, which takes advantage of this. Let's take a look at delegation. This is more about expressiveness. So how many of you are, I'm guessing everyone is familiar with the concept of dependency injection, right? Yeah, okay. So dependency injection, we have the concept of traits, which is the same as Scala. So basically they're like interfaces that can have implementations of certain functions, but they can't maintain state. So they can have properties, but they have to be abstract properties. And here I have a customer trait, which has a function getAll, and then I have a customer repository which uses that customer trait, a controller which uses that customer trait. I'm basically injecting that customer repository, and I'm assigning it to a private property, and then I'm calling customer repo getAll, right? The alternative to that is to have what's called a delegated controller, which basically here what I'm saying is that I'm still injecting that customer repository, but all of the functionality of that customer repository is delegated to the type, to this trait. Okay? So here I don't no longer have to have a private or a property, a private property referencing that dependency and calling it on that dependency. It's as if I mixed in this method directly into my class. Now you can do that on both functions, and you can also do delegation on properties. Okay? Now the question that arises here is what happens if I have 4 dependencies, for instance, that are being passed into my class? Doesn't that really kind of make it unmaintainable, because I have this class and I have these methods coming from everywhere, and unless I have some tooling, I have no clue where anything is coming from, correct? Because I'm not explicitly calling repository. And then the question comes back to why are you having 4 dependencies being passed into a class anyway? All right. Yeah. One of the benefits of using dependency injection versus service location is what? Who can tell me? Service location hides your dependencies, right? You're all familiar with the pattern of service location. I call out, get object, and say create service for me. It hides anything that that object does under the covers. With dependency injection, I'm passing in everything to a constructor. So therefore, I know everything that my class requires. And if my class starts to require too many things, that's a sign that my class is doing too many things. It's a sign that it's got too many responsibilities. What else do we have? So let's go to conventions. Here is again a data class. And what I'm doing is I'm overriding the plus symbol. So how do you do that? Well, I can extend anything, can't I? I didn't need to extend the data class. I could define a function that's called plus inside that data class. But I'm just showing you that you can also extend the data class. And I say plus data, and then inside this always refers to, in an extension method, this refers to the instance on which it's operating. So here basically I'm saying that if you do data 1 plus data 2, that's going to be adding the x of data and the y's, right? So I'm overriding the plus operator. And we use conventions to do that. So here are a bunch of other ones that you can use to override. You can override the inc, the dec, all of these things. So again, what does this give me in terms of real-world applications? Well, it allows me to be a little bit more expressive. If, for instance, I need to do something with a plus symbol, I could do it with a plus symbol, as opposed to having to write a method which says plus or add or whatever, if it makes more sense. Okay? And it's very easy to override these conventions. Pattern matching. I don't know if this really falls into the category of expressiveness, but I had to stick it somewhere as well because it's one of the things that is quite useful. Here you can pretty much, we're very flexible in terms of pattern matching. You can do on a single value, on a range of values, on a list of values, negate them. You can even call out to a function and then return the result of the function to see if it matches that pattern. And in terms of pattern matching, we had high goals in the beginning to do all these different types of pattern matching. But it basically boiled down to when statements for now. Okay? Okay, so let's see what a modern language looks like. And where are we? Modern. Oh, covariance and contravariance are also part of Kotlin. Right. So everybody knows that Java's finally getting lambdas, right? Everybody. We have lambdas or function literals. And this is how they're defined in Kotlin. And I'll show you a couple of things that we have which are exclusive to Kotlin. So here, for instance, I have a function that takes... Let me focus on this one on the screen. Yeah, that way you don't see any of the other ones. Here I have a function that is assigned to a variable add two numbers, and the function takes two integers and it returns the sum of those two integers. Okay? You don't need to explicitly say the type it returns because it can infer it. Now, here I have a function that takes a function, right? So it's a function that it's a high-order function. It takes a function. Basically, if you think about it, it's the same concept as strategy patterns, right? Whereas before, to do a strategy, implement a strategy pattern, you would have to pass in an object, and that object would then do the whatever. Here, I'm just passing in a function. It's the same concept, right? Except now I'm passing in a function without the actual object. So I have this strategy pattern, and this function that takes another function. So I just say this function takes a function that takes two ints and returns an int. Right? Easy. Now, here I have a class which is called a handler. And I'll show you where this is going later in a full-blown example that I'll show you. Here I have a class that's called a handler, and it takes a property which is called property. Okay, now here I have a function that, can somebody tell me what that does? What it takes as parameter? That takes as parameter an extension function on the class handler. That's pretty weird. And that's unique to Kotlin. And that's one of the powerful things that allows you to create very beautiful DSLs. I'm sure you've all seen the example of the groovy HTML builders written in a statically version of Kotlin, right? You've all seen that? No? HTML groovy builders, Kotlin. Fast connection here. It's a good thing. They said, do you need internet in your room? I'm like, yeah. Okay, well, one day that will come up. Oh, here we go. Type-safe Groovy builders in Kotlin. So one of the things that Groovy allows you to do is, define a nice DSL. So this is a I don't know how well you can see that, but so this is HTML, head, title, body, all of these things, right? And that's actually all statically typed. These are all functions, so if you click on this, it will show you the actual function implementation, right? Now, this is possible because of two things. One, that functions that take extension methods, and two, convention. We have a convention that if a function, and you can see here, if a function takes the last parameter is another function, you can drop the braces, the parentheses, right? So this is technically this, but you don't need to explicitly put in the braces, okay? As long as the last property is a function. Combining those two things allows you to create these DSLs, right? And in fact, one of the sessions that Andre is doing, I think either today or tomorrow, is using this concept of HTML builders for a web framework called Kara. Okay. We can even define these extension methods in line. So for example, here space replace is an extension method on the class string that takes a string and replaces the white space with a specific character. So now I could do some string space replace bar, and that would replace all of the strings with a character. Okay. So this is unique to Kotlin, the extensions of taking in functions that are extension methods to, or extension functions to a class, as well as some of the stuff in terms of conventions and that. Yeah?
So you're down, you have the example where you're using that extension function with the handler, the extension function with the property. Is that very similar to a with then kind of concept there in a way that, because I'm utilizing then the internal state to a degree. I have access to this guy implicitly. It's a strange.
No, I mean, this is, you're referring to this.
No, the line above.
This one.
Yes.
Okay, so what's happening here is that what I'm doing is, yeah, this is the actual usage. It's an extension function. Since it's an extension function, I actually have access to what? The class. Yeah. And therefore I have access to all the properties, functions, and everything of that class.
And this is the builder concept. This is how I make builders.
Yeah. But you can use this for other things, and I'll show you some examples later. The benefit of allowing you, I mean, the reason that this is good for builders, apart from the fact that, you know, you can drop the parentheses and all that, is that it's restricting what you can do. So it's defining the scope, right? As soon as you say that a function can only take an extension function, you're now limiting what it can do, right? Okay. So that's kind of some of the modern things. And I'll come back to this to see how you can actually use this in some applications. Now let's take a look at some of the safe aspects of the language. So this is, some call it controversial. I call it not controversial. I used to have a different opinion. I used to complain that classes should be open by default so that you can also always inherit from a class and do whatever you want. In Kotlin, classes are not open by default, they're closed. I also realized that long chains of inheritance are bad and they're horrible. I also realized that classes actually should be designed to be inherited from. So Kotlin made the choice of making classes by default closed. So if you want to be able to inherit from a class, you have to explicitly mark it as open. Now, whether you call that safe or not, it depends. Okay, let's go to immutable. Well, yes, it's pretty much the same as read-only properties, but we have the concept of immutable properties as well, and those can be both properties, they can be variables, etc. Sometimes I wish that by default everything was immutable in Kotlin. Unfortunately, there is no default. It's either var or val. Null safety. Kotlin does not allow nulls. That's simple. Okay? If I do this, it doesn't work because name is a string and it cannot take a null. Okay? So by default, nulls are not allowed. If you want a null, you can say that the string can be null. You put a question mark at the end, which means that this is a nullable type. Obviously, this is fully interop. So how do we work with nullable types? Well, if I do files, files test, list files, this is Java interop, right? This is Java IO file. I would have to check for a null. I would say if files is not null, then print line file size. Or I could just shorten it with the Elvis operator and say if it's not null, call size. If it is null, then don't do anything. I can also do the if else then. So here, if it's size, if it's not null, get the size. If it is null, then say file is empty. And if I want to be a pain and look for trouble, then I just do double exclamation mark, which means I know what I'm doing. I know that this is null, but call size on it anyway. Okay? This is what that means. Now, this the double exclamation mark is kind of like standing out saying, really, you want to call null on you want to call a method on something that could potentially be null. When you do interop with Java, you will come across this quite a bit. And there are ways to have Kotlin kind of not give you warnings or require you to put the double exclamation by using this library which we have called the K annotator. So it's a plugin that you can install into IDEA as well. When you open up a module in your project, it says you want to use K annotator to annotate this file. If you're familiar with, how many of you actually use IDEA, IntelliJ? Right. So all of the static analysis that we do is based on annotations, right? And you can annotate things too. K annotator is for that. Yeah. You can run the annotator on those libraries.
Even on a Java?
Yeah. Autocasts. This is kind of in the league of safety and also conciseness. I have a customer here, and it has a function called make preferred. So it says, if object is customer, object make preferred. Right, and you can see that this has kind of gone green, although I don't know if you can see, you won't see it in that screen, but it's kind of got a greenish background because it's automatically casting that to a customer, right? It says, I know that it's a customer, you've just checked that it's a customer, therefore I won't be a stupid compiler and ask you to cast it to a customer because I know it's a customer, right? Okay, compatibility. All of this would mean squat if it's not compatible. So here's, for example, using JUnit. Right. I take the test annotation in JUnit and I rename it to test. I can rename this to specification because I like specifications. And I can, that's it. Fully interoperable with JUnit, with everything. It's interoperable. Here, for example, is netty. How many of you have heard of netty? Right. So that is netty request handler, which is a Kotlin class implementing the channel inbound message handler adapter on object, which in Kotlin is called any. The top level object in Kotlin is called any. Okay? So there's full compatibility with all Java libraries. And there's some things that have been added, like, for example, recently we added support for SAMs, which is single abstract methods. So, it's fully compatible in that sense. Okay. So now I'm going to show you some other things with Kotlin. So what are others doing with Kotlin? How many of you here have actually, there might be a chance that you've actually written an application and deployed with Kotlin? No one?
We have Kotlin in our app. We build it with Java, mixed it.
Okay.
We're mixed with it.
Okay. How's that working? Good?
It's fine.
Okay.
Pickle and plain.
Okay. There is actually a functionality in the IDE also that if you take a Java file, you can right-click and convert it automatically to Kotlin. Or if you paste some Java code, it will automatically convert it to Kotlin. It doesn't work very well a lot of times, but most of the times it's okay. So what are others doing with Kotlin? First of all, there's quite a few people that have realized that the Lambda syntax, or the function literals, are much more concise. And they don't require a lot of code. And what they've done is they're starting to write Android applications using Kotlin. And there's a couple of Android libraries and wrappers already on GitHub that people are using to write Android applications in Kotlin, because the amount of code is substantially cut down. I mean, I can't give you rough figures, but I could probably safely say that you would end up with around 60% of the original code if you're using Kotlin versus something like Java. Okay? So there's the Android stuff. Funktionale, I don't know why he named it that, is a extension. It's a library that this guy has written, Mario, that adds functional aspects to Kotlin. Okay, some other functional aspects. So if you notice, I mean, most of the examples that I've shown you, I've been declaring functions everywhere, and I've been passing functions everywhere. So in essence, you could say that Kotlin is a functional language. I mean, it's got most of the characteristics that a functional language requires, right? However, there are some things missing from it, and I'm hoping that one day we can include some of these things in the standard library. So what Mario has done is, do you see this thing over here? It says, do you want to automatically annotate libraries in your project with KAnnotator? That's the annotations, and it creates the annotations in an XML file, and it puts them in your project folder. So here, for example, how many of you are familiar with the concepts of currying and partial function applications? Okay. So partial function applications basically means that, for instance, let me show you this example here. I have a function that takes 5 integers, and it adds all of these integers. So when I do a partial 5, applying that function partially with 5, what I'm saying is that basically 4 of those parameters would be wouldn't be passed in, right? And what happens basically is that what currying does is take a function and then return a function that then operates on the other parameter of another function. Let me try and explain. Let's say you have a function that has 3 parameters. Currying that, what it will take is then take that function and apply, create a function that it takes 2 of the parameters, and then on that apply the 3rd parameter. So it drills it out, right? I don't know if I've explained that more or less, but there's another word for currying, which is Schona-Finkelization, named after the guy that originally came up with the idea, which apparently wasn't Haskell Curry, but anyway. So what this does is basically say that I will add sums 4 to 10, right? Then I'm doing partially 3, partially 2. Now the problem with this, what I don't like a little bit, is that, yeah, you've got pretty much partially for every number of parameters of every function that you can pass in, potentially want to pass in, which normally you don't have too many parameters, so it wouldn't be that big of a problem. You have some composition functions. So here I can say add 5 and then multiply by 2. And all of these are basically built using the core concepts of Kotlin, which are infix annotations, which are extensions, etc. So there's no hack, there's nothing. He's just using the standard library of Kotlin to do these things. We already have quite a few of these functional things inside Kotlin, and I'll show you now when I show you some more evolved code. For example, reverse or match or repeat or map or transform. All of these things are built into the library already. Okay. So what else is going on? I'll come back to Wasabi. Kara framework, which is basically, how many of you know Rails? Right, so Rails is an MVC framework, and Kara is the same concept as Rails, but it takes it one step further and basically uses Kotlin to create HTML and CSS. And there's a session either today or tomorrow by Andre on this. One of the benefits of this is that in terms of CSS, if you've worked with CSS, we've tried to hack around CSS quite a bit with things such as less, because less allows us for inheritance. So you can already have this because Kotlin allows you to do inheritance. So if you have a strongly typed CSS, there's no longer a requirement for something like less because you have it as part of the language. Okay. Spec is a little experiment I put together, which is, if you've heard of BDD or behavior-driven development, which really is not a tool. I hate saying that it's a tool. It is not a tool. But there's so many people that are creating tools around BDD. I like to call them specifications. And basically here it's instead of a test, this is actually a unit test, but it's more explicit. So I say given a calculator, and then the first line is instantiating the calculator, then on-calling sum with two numbers, and then I get the sum of the two numbers. It should return the sum of the two numbers. So it's very explicit. And again, using what I was mentioning to you, the extension method, the functions that take extension methods, that's how I'm limiting the scope. There is no way that you could ever put that it, for example, or put that on outside of the given or outside of the it. Why? Because they're methods of those extensions that you're passing in. So it's very good for restricting the scope of how you can write your DSLs. This is on GitHub. How many of you have played with WebStorm or with the live edit features of WebStorm? So we've got this IDE, which also is supported in IntelliJ, WebStorm, which is an HTML editor, JavaScript editor IDE. And one of the features it has is that as you update your HTML, your CSS to JavaScript, without a browser refresh, but actually hot swapping using Chrome technology, it changes elements. So you constantly get an up-to-date view of your HTML, right? That's part of WebStorm, and it has been for quite a while. So that plugin is a Chrome plugin, which is actually built in Kotlin, and then compiled down to the JavaScript, and then ships as a Kotlin, as a Chrome plugin, right? Point being that although most of the focus of Kotlin right now has been targeting the JVM, JavaScript is also a serious target for us, and there's already products that are successfully being used now written in Kotlin. So let me go back, and I want to show you another thing. This is a little bit something I've been working on. Right. How many of you do web development? What frameworks do you use? Give me a couple of names. Wicked? Yeah. Okay, that's right. I've heard of bloody every framework apart from Wicked. Right.
We still use
Struts. You're ashamed to say it, no? Right. Not by choice. Right. Who's heard of Rails? Obviously, you've all heard of Rails, right? So I almost wish to forget that. How many of you have heard of another framework called Sinatra? Okay. So I fell in love with Sinatra via this other framework called Express.js, which is a Node.js framework. And I fell in love with it because of the simplicity of the framework, because I come from an MVC framework, and I was doing the whole model view controller and the whole views and all of that things, and it started to become too complex in a sense that it was just so much overhead every time you wanted to write something. And I have this obsession and passion for HTTP, which is actually quite frightening, but I really enjoy reading the RFC. Unfortunately, it hasn't been updated for over a decade. But I fell in love with Sinatra because of the simplicity and because it embraces HTTP as an application protocol versus what the majority of us are using it as a transport protocol. And I started to do web development in Express.js. The problem is that there's one minor issue with Express.js, which is it's JavaScript, right? And I hate JavaScript, right? And I say JavaScript is like taxes. It sucks to have to pay it, but you try and keep it clean when you do, right? And to a minimum. And I fell in love with Kotlin, and that's why I'm more involved with Kotlin at JetBrains. And I thought, well, you know what? I'm going to try and create something like Sinatra with Kotlin. And what I've come up with is a framework which code name wasabi, which is actually not very good because when you Google wasabi, well, okay. And this is using some of the concepts that we've just seen. Okay, so Sinatra is basically a framework which you pass in a path, pass in a route, and then respond with a handler, a route handler. And you have access to the request and response objects in that route handler. Okay? So normally you fire up a server, which in my case is called the app server. Forget this line. Then I do get, post, I have all of the verbs on this server. And here, for example, I'm doing get person and returns get persons. Now, what is get persons? That's actually a route handler. But if we go to the get, you can see what this is. It's a variable array of extensions on the class route handler. So var arg in Kotlin means that you can pass one or multiple arguments. And you can do that with functions as well. Right? And these are extensions on the class route handler. What is the route handler class? It's a class that has, that's not needed, a class that has a request and a response property, and it has a next method. Okay? What is route handler here is just a function that declares, it's syntactic sugar. I'll show you where this comes in now. So basically, this is a function that takes a route handler extension and returns a unit. And all it does is return itself. Okay? So let's go back to where we were, and let's see what getPersons is. Now, I could actually remove getPersons here and write my route handler here. And I could do something like response. See, I have access to response. And then send, for example, this is some text, right? And that would just print out some text. But I'm not doing that there because that's not really maintainable code, right? If you put everything in there, you're going to have a really long file. So I delegate these to functions. Now, in Kotlin, similar to JavaScript, you can actually call a function without explicitly assigning it to a variable. So you could do something like getPersons using the : annotation, similar to JavaScript where you can just call a function, right? The problem is that right now that syntax notation doesn't work on extension methods. So I have to explicitly declare it, but that is going to come into the language. So you will be able to do this without having to declare it to a variable. And if I go to getPersons, if it would work, you can see that this is a route handler, and all it does is just do response send, right? Now, inside that function, I have access to a request and a response. I'm doing response send. Now, this framework automatically takes care of everything for you. So send is sending back an object, right? And people is an array of type people. When someone calls this, it will send them back an array of JSON objects. And it does that because of this line over here, which I said forget about, which is negotiate content. So negotiate content automatically takes the accept header that's coming in from the browser. It parses it based on the weight that is required, because you know that browsers can request different types of content types. Parses it, gives you an order, tries to negotiate that, finds the serializer, serializes the object, and sends it back. Okay? So that's basically the flow layout of Wasabi. It's just a routing table, and then you offload to route handlers. And here, for example, is getPerson by ID, where you see now I'm using some of these functional approaches. So I say person, in the people, find. Find takes a predicate. It refers to the actual iteration over the array. So it's taking an array of objects, so it refers to a single entry in that array. And it says if the ID is equal to the root parameters to int, yes, I don't do any error checking there. If it's not null, send back person. If it is null, set status to not found. Okay? Create route handler. It takes the request body parameters and deserializes them. So I'm pushing this as JSON, and it adds to to the array, and then sets the status, sets the location, etc. Okay? Now, all of this is basically the core of the whole Wasabi is nothing. It basically just takes a request and sends back a response. That's it. Most of the things in Wasabi are built using extension methods. Sorry, using interceptors. And if you take a look at this negotiate content, what this is actually an interceptor, except what I do is make an extension function on app server to make it nicer to configure. So the app server has a list of interceptors, and it says interceptor request, before the request, after the request, etc. And what I'm doing here is basically just adding a helper method to make that configuration easier, right? Since I'm using an extension to app server, I don't need to do this. By default, by convention, Kotlin assumes that it's inside that actual class. So you don't need to do this .intercept. It knows it's in the app server. Intercept is a method of the app server. So I say intercept, and then the interceptor takes an interceptor and then tells me what paths it wants to intercept and when it wants to intercept it, right? And then the actual interception just is an interceptor trait, which has a single method, which is called intercept, which takes the request response and then returns true if you want the process to continue or false. Okay? So everything here you can see basic authentication, basic authentication, content negotiation, fav icons, file-based interceptors, all of it, all the functionality of Wasabi is basically based on this concept of interceptors. Okay? Now, I showed you with this that we're using some of the functions of Wasabi, of Kotlin, which is basically the root extension handlers. Some other things that you could do are things like this. So I could do, for instance, app server get something. And then I could do negotiate. Why is this giving me? Oh, did I kill this? So I have another one which is called response negotiate, right? And response negotiate takes an array of pairs. Now, who's familiar with content negotiation? Basically, a request comes in as application JSON, do this. If it comes in as text HTML, do that. That line that you saw previously, this one does automatic content negotiation. But you can also do manual. And you could do something like text HTML with response send hello. And if you want application JSON with response send some JSON here, etc. Right? And this, what this is doing is basically using extension methods on strings and infix notation to define the with. And it's combining that with root handler extensions so that you could do response directly here, right? But you don't need the response here. You don't need the response here. I could actually just do send because it's in the context of the response already. Okay? So it makes a very fluid code. So, any questions? I would run this, but trust me, it does work. Okay, so are we there yet? No, we're not. And we're not there yet for a couple of reasons. First of all, the speed of the compiler, right? Right now, I'm not going to lie to you. You're going to try it yourself, and it's not the fastest compiler in the world. And we do want to make it as fast as Java, right? So a lot of effort is being put now into making that compiler fast. Are we there yet in the other goals? We're not there yet in tooling either. I mean, IntelliJ already provides you with a bunch of refactorings. It provides you with static analysis. But there's still a lot more left to come. So if we're looking at those goals, we're not there yet in those two aspects, right? Now, the tooling can eventually come, but the important one, which is the compiler speed, needs to speed up. It doesn't mean that you can't use the language. As I said, we're using the language internally. However, it's not the most ideal experience when it comes to compile time. Right? I mean, for example, for me to compile Wasabi, which is quite actually little code for all it does, which is the benefit of Kotlin, but it takes around 10 seconds now. Okay? The overhead, there is no overhead. Right? There is no overhead. You don't have the overhead that Scala has. Right now, Wasabi even, someone was complaining about the load time of JVM. I have 34 integration tests with Wasabi, which basically means that every single test fires up an instance of an HTTP server, runs the requests against it, and does the comparisons. And with 34 tests, it's taking me under 1 second to run all of those tests. Okay? It's using Netty under the covers, which I love. Okay? Wasabi is using Netty. But in terms of tooling, in terms of speed, no, we're not there yet. So if you've liked what you've seen and you want to play with Kotlin, it's completely free. Obviously, you can download the command line tools. The IDE is also free. All of the things that you've seen and everything that would be possible in Kotlin is always going to be supported in the IntelliJ Community Edition. You're not going to need Ultimate to be able to play with Kotlin. The Community Edition of IntelliJ is also open source and free, available on GitHub. If you want to play with the web interface, there's a web interface on kotlin-demo.jetbrains.com, and the source code is on JetBrains/Kotlin. And we do have external committers to JetBrains as well. More information, the homepage is kotlin.jetbrains.org, and we have a Twitter handler, which is Project Kotlin. And I'm going to be at the booth this next 2 days, so if you do have any questions, please feel free to stop by the booth. Thank you.